Now let's take a look at short-run production costs. We're still using our example of a workshop that produces chairs. So in the left column under Q, we have the number of chairs per day that the workshop could make. And then there's three types of costs. There's the total fixed cost, which is a fixed cost is defined as a cost that doesn't change regardless of the quantity that we produce. There's total variable costs. So these are costs that increase as we increase the number of chairs that we make. And then there's total costs. So beginning with total fixed costs, these are dollars per day. Just as Q represents the number of chairs per day, the cost will be dollars per day. So our total fixed costs are $100 per day. So as the definition says, regardless of the number of chairs that we produce, this cost is a cost that we're going to pay. So our column will be filled with $100. Now, the total variable costs, so these are costs that increase as we produce more chairs. So if we produce no chairs, our total variable cost is 0. And if we produce one chair, we find that our total variable cost is 90. If we produce 2 chairs, total variable cost is 170, and so on. Now, our total cost is determined by adding our total fixed cost to our total variable cost. So we find the total cost of producing no chairs is going to be 100 plus 0. So this equals 100. The total cost of producing one chair is going to be 100 plus 90. So this equals 190. And then we can continue down. Now this gives us our total cost data. Now if we were to graph this data, we'd find that our total fixed cost is a horizontal line. So this is total fixed cost at $100. And so what it shows us is regardless of the number of chairs that we produce, the cost is going to be $100. So we can see now if we graph our total variable cost, it will be 0 if we don't produce any chairs. And so we'd have some sort of upward sloping line. So this would be total variable cost. And then to determine and graph the total cost, we would just add the total fixed cost to our total variable cost. And so we'd end up with a line that would look something like this, where the distance between the two lines is $100. Now the total cost data is important, but its main reason why we need to calculate it is so that we can calculate our average cost data or our cost per chair. So what we're interested in determining now would be our average fixed cost, so AFC. So this is equal to our total fixed cost divided by our quantity. So if we were to calculate this now, we'd find that total fixed cost of 100 divided by 0 if we produce 0 chairs doesn't give us a number, so we don't have an average fixed cost for no chairs. If we produce one chair, our total fixed cost is 100, and so our average fixed cost if we produce one chair is $100. 2 chairs, we find that the total fixed cost is 100, so now divided by 2, our average fixed cost is now 50. And then the third chair is 33.3, repeating, and we just continue down the line. And that gives us our average fixed cost. Now we're also interested in our average variable costs. And this is equal to our total variable costs divided by Q. So again, if we don't produce any chairs, there's no variable cost, so we don't have a number for 0. If we produce one chair, our average or our total variable cost is 90, so our average variable cost per chair is 90. We produce 2 chairs, it's 170, so 170 divided by 2 is 85. 3 chairs, the average variable cost is 80. 4 chairs, the average variable cost is 75, and so on. Now, if we look at average variable cost, we see that it begins at 90, then decreases down to 74, and then it begins to increase again. So we've got reducing average variable cost and then increasing average variable cost. Now, the reason we see the increasing average variable cost is due to the law of diminishing returns. Now, the next one we're interested in is average total cost. And average total cost equals total cost divided by Q. So we can go ahead and calculate that. Again, if we don't produce anything, there's no average total cost. If we produce 1 chair, our total cost is 190. And so our average total cost per chair is 190. If we produce 2 chairs, our total cost is 270 divided by 2. This gives us 135, and so on. Now, we can calculate it by dividing the total cost by Q, or we can just add the average fixed cost and the average variable cost, and it will provide us with the same number. So we can see 100 plus 90 equals 190, 50 plus 85 equals 35, and so on. Now, the cost that we're most interested in would be marginal cost. So our marginal cost is going to equal our change in total cost when we change quantity. Or in other words, we want to know what is the cost of producing that 1 more chair. So again, if we don't produce any chairs, there's no marginal cost. If we go to produce our first chair, our total costs go from 100 to 190, so the marginal cost of producing the first chair is 90. The marginal cost of producing the second chair, our cost increased from 190 to 270, so the marginal cost is 80. The third chair, our costs go from 270 to 340. So our marginal cost is 70, and we can continue to calculate these. And so we can see our marginal cost begins at 90, reduces down to 60, and then again begins to increase up to 110. And again, this is due to the law of diminishing returns. To graph the average cost curve, we'll create a chart. On the vertical axis, it'll be costs, and the costs now are dollars per chair. And on the horizontal axis will be quantity still, and it's chairs per day. Now, if we're going to draw a line for our average fixed cost, it would start at 100 and then drop quickly. And then the more chairs we produce, the closer it gets to the horizontal axis. So this is our average fixed cost. Now to draw our average variable cost, it starts a little bit below, and the average variable cost, if you recall, decreases to a certain point, and then it begins to increase. So this would be our average variable cost. Now to draw our average total cost, we're going to take our average fixed cost line and add it on top of the average variable cost. So if you can imagine adding these two lines together, so the total cost, or the average total cost curve then would start way up here, and then it's gradually going to approach the average variable cost and get closer and closer and closer. Now the key is when we graph our average marginal cost or a marginal cost curve is mathematically it has to intersect the lowest point on the average total or on the average variable cost curve and the lowest point on the average total cost curve. So when we graph it, we find it decreases and then increases, so intersects at the minimum there and intersects at the minimum there. And then this is our marginal cost curve. And again, It's mandatory that the marginal cost curve intersects the minimum of the average variable cost curve and the average total cost curve. And these 2 points are interesting. Very important points for us to consider when we begin to look at how many chairs would we produce and at what price would we begin to make an economic profit or not make an economic profit, and more importantly, when would we shut down?